Hello everyone. Let's take a look how to remove the middle element of a linked list. So we think about the conditions first. So what if the list is empty? So if the list is empty, we just return null. So what if the list only have one item? So we just remove the only item and return null. So what if the list has odd number items? So like 1, 2, 3. So for this case, we can just remove the middle element and return 1, 3. What if the list has even number items? So for example, 1, 2, 3, 4. To simplify this question, we just return the right middle. For this case, we are going to remove 3. We get 1, 2, 4. So yeah, this main function, the first step, we are going to build up the list. So first we input the number element for this list. Then we use a while loop to take in all the inputs for the list. So if the head is null, so we build up the head. At the meantime, we also maintain the tail because we are going to add the element to the tail of the list. So if the head is not null, we are going to add the list to the tail next. Then we reset the tail each time. So by doing this, we have for example, we input a file for the count, we get 5 elements of list. So for this one, we are going to print out the original list. This line, we are going to remove the middle for the list. Then we print out the result. So let's take a look at the node data structure. So the node data structure, it has a data field, a next pointer to the next. So this is the definition of our linked list data structure. So in this utility class, we are going to demonstrate. One is print out the whole list. Second, we are going to remove the middle element. So for this function, so we use a while loop to check whether the head is null or not. If it's not null, we print out the element. Then we move to the next. By doing this, we print out the whole list with the space in between of the elements. So this function is the implementation of removing the right middle element for the list. So first we check if the list is null, so we just return null. If the list only has one element, we also return null. So for this one, we need to save the previous node because we are going to link the previous node with the middle element next. So we set the one pointer, which is the slower pointer, pointed to node.next. And we need a faster pointer. We are going to point this one to node.next.next. So at the moment, the 2 pointer, which is the faster pointer, reach to the tail. The 1 pointer will point to the middle. So this is the condition of our while loop. So each time we move the 2 pointer 2 elements. Each time we move our 1 pointer 1 element. So before we move our 1 pointer, we save the current 1 as the previous. So at the end, if the 2 equal null or 2.next equal null, the 2 pointer reach to the tail of the list, then the 1 element is point to the middle. So the last line is going to link the previous dot next to the middle's dot next. So by doing this, we remove the right middle. So let's take a look at our output. So first list, we build 1, 2, 3, 4, 5. With 5 elements, it's odd number, so we just remove the middle. So we get 1, 2, 4, 5. The second list, we have 6 elements. It's even number. So for our case, we are going to remove the right middle, which is 4. So we get 1, 2, 3, 4, 3, 5, 6. Okay, let's think about how about we just remove the left middle. So for this case, 1, 2, 3, 4, we remove the 2, which is the left middle. We get 1, 3, 4. So we only need to change the 2 lines of code. Let's take a look. This is the whole implementation of our remove middle function for the right middle. So we change this 2 line. So previously, this one, the starting value for the 1 pointer is node.next, and for 2 is node.next. So if we want to remove the left middle, so we just point to node, the beginning of the list. And for the 2, yes, theme, we just point to node.next. Yeah, that's all the change for removing the left middle. So theme, we have 4 elements in the list. We remove the left middle. We get 1, 3, 4. So for the 5, the odd number of list, we just remove the middle 3. So we get 1, 2, 4, 5. We are still good. Okay, how about we want to remove both left and right middles? So like 1, 2, 3, 4, we want to remove 2 and 3. We get 1 and 4. So for this case, the key is we find out the count of the elements is odd or even. If it's odd, we only remove the middle. Otherwise, we remove 2 middles. Let's take a look at the implementation. So we need a flag. Use this flag and this condition. We are going to set whether the flag is true or false. If it's true, it's even number. If it's false, it's odd number. If it's even, we are going to remove 2 elements. So we point 1 dot next to previous next. So if it's odd, we only remove 1 element. Okay, let's take a look at the output. So for even number 6, we have 1, 2, 3, 4, 5, 6. This is the original list. After processed, we remove 3 and 4. We get 1, 2, 5, 6. So for odd number, we only remove 3. So we get 1, 2, 4, 5. And for odd number 4, 1, 2, 3, 4, we get 1 and 4. We remove 2 and 3. So let's think about the performance of the code. So for the time, no matter what, we need to find out the middle, right? So we need to go through the whole list. So the time is big O(n). For the space, we don't have to save all the elements for the list. We only save a few: the previous, the 1, and the 2 pointer. So the space is big O(1). Okay, thanks for watching. If you have any questions, please comment below. If you like my video, please don't forget to subscribe. I will upload more videos. You can reach me by this email, tomcoding51@gmail.com. Thank you.